Good morning, students. I hope you're all staying safe and doing well. Today we will discuss about a topic from chapter 5, Core Bank Systems, and the topic is CBS IT Environment, where we specifically discuss about the different kind of servers and the functionality or role of each server. Before we get into the main topic, let us ensure that you all understood what is a server. So once you understood the functionality of the server, then it is easy for us to follow the discussion. It's just that we are going to understand different kind of servers. In chapter number 4, when we are discussing about different types of system architecture, we discussed on two-tier architecture and three-tier architecture. These two architectures are typically based on client-server architecture, where there will be a client and there will be a server. Client will send some request. So the request could be to access a certain information or to access a file, whereas server respond back with that request. So this is how basically the client-server architecture works. So we will also go through a definition once. The server is a sophisticated computer that accepts service requests from different machines, which are called clients. These requests are processed by the server and sent back to the clients. Even in the diagram, if you see here, there are 4 clients and they might access the server for different kind of purposes. Based on the request, the server responds back to the respective clients. So this is what a server means. Now we will move on to the main topic. Branches of the bank are connected to the centralized data center. Fine. If you see in India, I think everybody knows State Bank of India. Okay. This has approximately 44 crores customers and they have close to 22,000 branches and 58,600 ATM machines. Okay, so you can visualize the magnitude of SBI's network. Okay, and now in today's environment, let's say there is a customer. Okay, let's assume this is an SBI. One customer opens an account with branch A. Out of these 22,000 branches, he opened his account in one branch A, called A. And if he visits to branch B or branch C, is he able to do the transactions? Yes or no? Yes, right? He can perform the transactions either in branch B or branch C. Even for that matter, in any of these 22,000 branches, he can access his customer information and perform the necessary services. So how that can be possible? Only because all these branches are connected to a centralized data center where the data is stored at a single location, due to which, irrespective of the branch, he will be able to perform the requisite activities. Diagrammatically, let's see how it looks like. They are connected to the data center. Now, what is meant by a data center? Data center is nothing but a large number of computer servers which are connected through networks. This is a simple definition of data center. Okay. In this example, if you see here, there are so many servers, right? One is a database server, application server, channel server, and internet banking application server. So in this diagram, I have just given 4 servers, but in your syllabus, you have total 8 servers as part of our topic. Let us discuss in detail what each server means. So before getting further, you understand the context, right? So all these branches are connected to the centralized data center where you will have a large number of computer servers which are connected through networks. Due to this architecture, that customer is able to visit any of the branch and get the required services. Okay. This makes the customer is no longer a customer of the branch, is a customer of a bank, right? So as they all access the centralized data center, they will have, each branch have the same level of information. Out of 8 servers, we are going to first deal with 2 servers. One is application server and then database server. What I'm going to do, instead of going to the definition and explaining you what is that server means, let us try to take a real-time scenarios and understand how these servers plays a role in that scenario, so that you will be able to easily understand the functionality or mechanism of each server. In this diagram, we are going to discuss about three scenarios. This customer can visit a bank branch, or he will be visiting an ATM, or he can log into the bank portal via internet banking. So these are all the three scenarios using which we are going to continue our discussion. In first case, this customer is visiting a bank branch. Okay. Now, in the bank, there will be employees who are sitting in front of a machine, right? These are called clients. We already know what is a client and what is a server. So all the bank branches have a client machines which are connected to the servers, which are located in the centralized data center. Now, in this example, this customer wants to withdraw money from his bank account. So he visited a bank branch and submitted the withdrawal slip to the bank employee. What the bank employee does, he does some basic validations. Like in his machine, he will be entering the account number and checking whether that account number exists or not, and whether this user is the authorized person or not to withdraw the funds, and also whether the sufficient balance existing or not. So some basic validations are done at a branch level, and then finally, after all these basic validations, if he confirms that there is a sufficient balance, he passes the withdrawal entry in the books and then gives the cash, right? This is the scenario. Now, from the IT or a network point of view, how these transactions in the backend happens is what we are interested in now, because in real time we all know how, when we visit a bank what we do. So now let's understand in the backend process. We already understood all these bank branches are connected to the centralized data center. Okay, so we also understood these branches are having client machines. So for sure there should be some servers. Where those servers will be located? They are located in the centralized data center. In our example, we are going to talk on application server and database server. Now what happens when the customer enters an account number here? The request comes to the data center, centralized data center. Okay. First, the request goes to the application server, and then finally it goes back to the database server, where in the database server, it consists of the entire data of the bank. Entire data of the bank is stored in the database server. And also, what kind of data it stores? It stores the account details of the customers and also some of the master data. Like you could have remember from chapter number 2, master data and non-master data, right? So in the banking environment, the master data is customer master, employee master, and example FD rates master, and penalties. This is just an illustrative list. So like this, they will have the account details of the customers as well as the all the masters. So you need to keep in mind, irrespective of the source, whether they access from bank branch or through ATM or internet banking or through any other source, finally the request has to come from the database server only. So the data is stored only in database server. They might maintain the backup servers, but basically it will be stored in the database server. So now we understood what is a database server. It contains the entire data of the bank, and it also holds the customer account information and also the couple of other master data. But when the client send a request, is that request directly comes to the database server? No, because if you provide access to the database server, there is a high risk that the data can be changed, because there could be certain data which this user is not authorized to access, that bank employee might not authorize it to access. So, and also the same database server is accessed by multiple branches. So that is the reason the access controls will not be able to implement it in the database server. So all those access controls and the respective business logic is implemented via application server, where the core banking software like Finacle. So there are many softwares in the market, right? Finacle, FlexCube, or even banks. So these are all the softwares which are installed on this application server, where it does all the required validations and the respective business logics can be built in the application server, not in the database server. Database server simply hosts all your data. Beyond that, it don't do anything. All the business logics and validations have to be kept in the application server. So the request comes from the bank branch to the application server, and after the required validations, this application server sends a request to the database server. In our example, where the customer wants to withdraw money, right? So the first step what the bank employee does, he enters the account number. He has to check whether the account number is existing or not. Where that information is stored? This information is stored in the database server, right? Database server. So the request comes to application server. In turn, application server accesses the database server and checks that account number is existing or not, and then confirms back to the client machine, which is the bank employee, yes, this account number exists. So this is how the process flow happens. Once he does the basic validations and he is about to give the money, he will be posting the withdrawal entry, right? Again, the same thing happens. When he passes the entry goes via application server, finally update the customer balances in the database center. Say example, previously before this transaction, the customer has a balance of 1 lakh. This is stored in the database server. Once the bank employee passes this entry, the balance should go to 90,000, right? So this will be updated in the database server. When he accesses through any other branch after this transaction or through ATM or internet banking, the balance should show as 90,000 only, not 1 lakh, right? That is the reason they will be having only centralized data server. So I hope you understand what is an application server and data server through this example, and we will also have a quick look on the definition. If we miss any point, we can discuss further. Application server. The application server performs necessary operations and update the customer account balances in the database server, right? So even this point makes it clear the data is always stored in the database server. Whatever be the updates you have to do it in the database server only. But as the access will not be directly granted to the database server, it goes via application server. And the second point, customer transactions at a branch level are validated locally and then transmitted to application server, followed by necessary updates in the database server. This I already told you, right? When the customer visited the bank branch, he does the basic validation whether the account is existing or not, whether he is the authorized person or not, and whether the sufficient balance is there or not. After that, the request goes to the application server and then finally database server. Now comes to the database server. The database server of the bank contains the entire data of the bank. We already understood that point. And the data would consist of various accounts of the customers and master data. Example, customer master, employee data, interest rate, FDs and loans, etc., etc. And application server would access the database server. I told you, right? The access will be via application server, right? This is the point they are talking now. So this is about application server and database server. Let's move on to the next topic. ATM Channel Server. This is the third server we are going to discuss now. In the first case, the employee visited the bank branch and performed the transaction. Through that example, we understood what is an application server and database server and how they plays a role in that process. In the second scenario, the customer is visiting an ATM for withdrawal of cash or even a mini statement. You can take any example because nowadays ATMs are very powerful. Lot of operations can be done via ATMs. So for our example sake, let's take he's trying to withdraw the money from the ATM. Again, as I told you earlier, irrespective of the source, the data is always stored in the database server. Okay, so finally the transaction has to hit the database server, which is located in the centralized database server. Now let's see how this transaction will be happening in the backend. The moment the customer insert his card and enter the PIN, in the back end, the request first goes to the ATM switch. Okay. This ATM switch is also a server actually. This is not form part of your syllabus, but in the process, ATM switch plays a key role. What it does, it checks whether the card belongs to the respective bank or even from other banks. Nowadays, you need not use your SBI card ATM in the SBI bank ATM only, right? That debit card can be used in any other ATM and withdraw the funds. So how those systems works? So using this ATM switch, it will route the transaction to the respective bank. We need not get into the topic. It's again a big topic altogether, how that routing happens, how the validation happens. But just understand, in between there is a server which validate whether that card belongs to the same bank or not. Once it does, it will pass on to the database, the centralized data center. Now, there is a new server now. Previously, we understood what is an application server, what is a database server. In this context, there will be a new server called ATM Channel Server. As and when banks issue an ATM card to the customer, his details are stored. So, ATM customer details are stored in this server, where it says, okay, this is the account number and this is the customer name. Now, when he insert his card and enter the PIN, after the validation, the request comes to the ATM Channel Server, where it does that validation. Yes, is a genuine customer of this bank, and based on the request, it will finally route the transaction to the application server. In turn, application server connects to the database server. This channel is same. Okay, even in the previous example, the access to the database server goes via application server. Here, one more layer got added since the transaction is happening via ATM. So in the ATM channel server, it stores the ATM customer details. And there is also additional functionality in the ATM channel server. What it does, sometimes this centralized data center will be busy during month end or period end time. There will be a lot of transactions that are getting posted. So in such cases, if the server is so busy, sometimes the request may not be able to cater, or it might take a longer time to respond, right? So in order to avoid that kind of scenario, what they does, this server will send all the customer balances in a file. Okay, customer A will have a closing balance of 1 lakh, customer B will have a closing balance of 50,000, like this. And this file is called positive balance file. Okay, so that means for this kind of data, the request need not go to the database server. Instead, it can be stored in the ATM channel server only. So during that time, example, if any customer wants to withdraw the money, when the request comes to the ATM channel server, using the positive balance file, the transaction will get authenticated and funds can be withdrawn. And once the centralized database server is free, the updated balance will be sent back to the database server, so that the actual balances will get updated in the database server as well. Okay, these are all the two functionalities. One is it stores the details of the ATM customers, and also at the time of centralized data server busy times, it maintains that positive balance file as well. Now let's have a look at the definition. ATM channel server. It contains the details of ATM account holders. We already discussed on this point. When the central database is busy with end of day activities or for any other reason, the file containing the account balance of the customer is sent to the ATM switch. Such file is called positive balance file. Once the central database server becomes accessible, all the transactions that took place till that time would be updated in the centralized database. Right? So what is the objective of it? This ensures not only continuity of ATM operations, but also ensure that the centralized database is always up to date. Okay. So fairly enough, I hope you understood what is an ATM channel server now. So far we covered about 3 servers: application server, database server, ATM channel server. We will be discussing on with the next example 3 more servers: internet banking channel server, internet banking application server, and web server. Now, this time Customer is trying to access the bank portal via internet banking from his laptop or a desktop. Basically, before we understand what happens in the back end, let us try to understand what happens in the front end. So let's say I want to access the ICICI Bank. What I does, I open my laptop, I open the internet browser or any browser for that matter. I enter www.icicibank.com. Right, that is what I does from the front end. But what happens in the back end, we are least bothered. Now let's see what this process happens. Now, when the customer enters www.icicibank.com, the request first goes to a web server which is located in the centralized data center. Okay, all these servers are located in one place only. Okay, I need not repeat it again and again. So the first request goes to this web server where the website related information and the related softwares are stored. The moment you enter that URL, it goes to the web server and it pushes back with the website. The website will get loaded onto the user machine, right? That is the functionality of the web server. And what happens next, you will be clicking on the login page, so where you are required to enter your username and password. The moment you enter username and password, again the request from web server goes to the internet banking application server where the internet banking software is stored. Okay, and in turn this server access the internet banking channel server where the internet banking username and password is stored. So don't get confused with the names, try to understand the functionality so that it will be easy for you to remember. Like you understood the flow, right? When he entered the username and password, first it will be request goes to the web server, which in turn talks to the internet banking application server, and internet banking application server will raise a request or validate these credentials with the internet banking channel server. So where the internet banking username and password is stored, it is nothing but internet banking channel server. Once the details are validated, then it goes back to the main application server and also access the database. Example, if you want to download your account statement, after this user name and password validation, the request goes to the database server, because the data, ultimately your data is stored in the database server only. How it goes? The request goes from here to this database server. But in the database server, the data is stored in a tabular format. So it can't be shown as it is, right? So that's the reason they use one more server called middleware. This is yet another server, but it is not form part of your syllabus. That is the reason I haven't kept in this diagram. So using this server, the data will be translated in the way user can understand. Means when you finally give your from period and to period, the statement can be shown in different ways. One is on the screen, one is in the form of PDF and Excel, right? So that conversion is done by the middleware software. Don't worry about it, but you just understand the functionality. Now that request will come back to the that user machine. So this is how the internet banking process happens. Now in this process we understood what is a web server, internet banking application server and channel server. Let's have a quick look at the definitions. Web server. Web server is used to host all web services and internet related software. It is a program that uses HTTP. What is HTTP? Hypertext Transfer Protocol. Means when the user is sending a request to the server, it has to follow certain rules and regulations, means for the data transmission. In this case, it's called Hypertext Transfer Protocol. Using that protocol, that request goes to the web server and again the server responds back with the requisite information. All computers that host websites must have web server programs, right? All these websites are indirectly stored in the web server programs. You might have a question like many times even you or me can have our own website, right? when we are opening this website, are we maintaining the web servers with us? No, those are leased web servers. Those are leased. Example, you could have heard this guy, GoDaddy, where one can host their website. You can buy a domain name and also host your website. So these guys maintain the web servers. It is not our responsibility. All we do is on a yearly basis we pay certain rent to these guys, right? But whereas in bank's case, they can't depend on these guys, third-party vendors. There is a high risk because the data is very sensitive, and also there should be 100% uptime. So if the third-party vendor is unable to fulfill that, and if the servers are not in a position to accept the request, there will be a huge reputation loss for the bank, because 24/7 the server should be up and running, and especially due to the security reasons, the banks maintain their own web servers. So that's the only difference. In individual case or a personal case, even though we can have a particular website with us, we need not maintain the web servers, but in a bank's case they should maintain the web servers. That is what the third point. All computers that host websites must have web server programs. So this is about web server. Now internet banking channel server. In the previous example what I told you, when the customer enters username and password, the request goes via web server, internet banking application server. Finally it goes to the internet banking channel server, where the username and password is stored. And apart from the username and password, it also stores the information like which branch this customer belongs. This is additional information is stored by the internet banking channel server. Now the third one was internet banking application server, where the internet banking software is installed. Okay, similar to the application server where the core banking software is installed. See, you can get a doubt like, we already have one application server, why we need to have additional application server? It is just to manage the load, because there could be huge number of people connecting via internet banking, right? So they just separated it so that these two servers can manage the workload. And what it does, it basically authenticates the customer with the login details stored in channel servers, right? We already understood what is that authentication. The request goes to the channel server, it checks whether that username and password is correct or not, then it sends back that request to the application server and web server, finally the database server, right? So this is how the web server, internet banking channel server and application server are correlated and plays a role in the internet banking process. I hope you are all with me and able to follow the topic. Now let's quickly complete the rest of the servers as well. Now the next server is a proxy server. Now this proxy server concept is generic in nature. It need not be in the banking environment. Even in a standalone environment, even companies will have the proxy server. Okay, so if you understood the objective of having proxy server, then the same holds good for the CBS environment as well. Let's say there is one user, he is trying to access a web server for the website. Example, even in the previous example, we discussed that he enters www.icicibank.com and the request goes to the web server, and after validation, the website will be loaded onto the user, right? Now, how these two machines are connected via internet. In general, if one wants to go to a particular place, he need to know the destination address, right? At the same time, even in the internet, if the user, if this user sends that request, it should have the destination address to where this request has to go. The destination address is nothing but the IP address. Okay, so this machine is identified with this address 23.65.75.88, and this machine is 192.158.1.38. so this is their addresses. So the request goes via internet and finally reach to the web server, right? So when he is sending the request, so using this I told you, right, that HTTP TCP/IP protocols, so it knows that the destination address is this, and finally it reaches to this web server. And again, when this web server responds back to the user, it also knows to where that information has to send. But what happens, all these things are happening in the public internet, right? We are connecting from our homes or offices to the bank's portal. So there is a high risk of hackers. So what they do, so they will observe this data and get these IP addresses. This IP address is, let's assume that this web server is belongs to a bank. So once they know the IP address, so they will try to hack this machine. Because they know the address, they'll try to hack the machine. So that is the major risk we are going to address now. Till here, I hope you understood the concept of hackers, and especially when they are trying to access the information over a public network. Now, what is the solution for that? In this, we will be introducing a proxy server. What happens? See, apart from the proxy server introduction, the process holds good. Means even in this case, this user trying to access that ICICI Bank portal. So previously, the request used to come directly to the web server. But with the advent of proxy server, the request this time comes to the proxy server, and proxy server creates one more request to the web server. And when the web server responds, it comes to the proxy server, and proxy server responds back to the customer. This is how it happens. So even in this case, see, we can't avoid the hackers who are there on the internet. All we are doing was how best we can protect ourselves. Like assume that this is a bank environment. So this proxy server is exposed to the public internet, whereas the web server is not directly exposed. So the request comes to the proxy server. So even in this case, if this hacker got an IP address of this, he can't do anything because proxy server doesn't have any data. It doesn't have the website related pages or website related information. It's just kind of a gate. Okay. So max to max he can get into this level, but from here to here he can't go. There is a lot of protocols that will be placed in between. So this is the concept of a proxy server. Now there is one more functionality of the proxy server. Let's say this is one user, right, ending with 38. There is another user 40. He also want to access ICICIbank.com. When he sends a request from his machine www.icicibank.com, the request this time also come to proxy server. But what happens, just a few minutes ago this customer requested the same information, and the information is already is there in the proxy server, right? So it stores temporarily in its cache. Okay, this time again it need not go back to the web server for that information. So instead of it, from its cache memory only the request is served back to the clients. So what is the advantage of this? So you are avoiding this request, right? So that means the bandwidth and network network request can be saved for the main server. So this is the one more advantage of proxy server. I hope you understand the concept of proxy server. Now let's see the definitions. A proxy server is a computer that offers a computer network service to allow clients to make indirect network connections to other network services. In the previous example you see here, so this is an indirect connection, right? Earlier he used it to make a direct connection. Now this is an indirect network connection. When the request comes from the user, okay, there will be an indirect connection from the proxy server to the other network services. Now a client connects to the proxy server and then requests a connection or a file or other resources available on a different server. In our example, when he tries to access the web server to load that ICICI Bank portal, in between the proxy server take that request and get the requisite information from the web server. Now the third point, proxy provides the resource either by connecting to the specified server or by serving it from the cache, and hence often used to increase the speed and manage the network bandwidth. I told you, right, in the previous example, when this customer customer B trying to access the same portal, this time the proxy server will not send this request to the web server because it already knows what it has to do. So it simply sends from its cache memory only. So that's the reason the speed and network bandwidth can be saved. The last point, serves as an intermediary between the users and the websites they browse for, right? So it's an intermediary between the actual user and the web server, right? So I hope you understood the proxy server. Now let's move on to the last and final one, is antivirus server. Very easy to understand the antivirus server. It is not that difficult. See, usually in our personal machines, when you install the antivirus software, that will be protecting only your machine, okay? But think from the bank point of view. In the starting of this session, we discussed about an example from the State Bank of India, where they have 22,000 branches. Assume that each branch have 5 machines. So 22,000 into 5, approximately 1,10,000 machines they have. So do you think that they will install this antivirus software in those 1,10,000 machines? No, for sure. It requires a lot of time and lot of cost also involved, because you need to procure those many licenses, okay? And also assume that, okay, for some reason you decided to go ahead in procuring 1,10,000 licenses and installed on each machine. Assume after some point of time you want to change the antivirus software. Again, you need to do this activity on all the 1,10,000 machines, right? So what is the best solution for it? The best solution, instead of having it a decentralized location or at a client level, keep it the antivirus at a server level. Again, till now we discussed about 7 servers. In which server you are going to install the antivirus? So if you install in one server, what about the other servers? And also each server is designed for a specific purpose. So you can't put this antivirus software in that server. So the best solution was to have a separate dedicated server for installing your antivirus. Okay, let's see diagrammatically so that you will be able to understand. Now all these bank branches are connected to the database center, and in this database center you will have a separate server now called antivirus server. In this server you just install your antivirus software, and whenever any connection request happens from the branches or ATM machines or internet banking, this server will scan that request for any malicious viruses or attacks. And also it scans the other servers as well whenever they are installing new softwares, so that the malwares or viruses can be scanned and quarantined. So this is about antivirus server. Let's have a quick look at the discussion. The antivirus server is used to host antivirus software. Understood. To ensure all the software deployed are first scanned, so that appropriate virus or malware scans are performed. So whenever you are installing a software in the entire data center, it will be first scanned by the antivirus server, and then it allows for the installation, right? So this is about antivirus server. With this, we completed all the 8 servers. I hope you understood now about each server and what is the functionality of each server. I'll be showing one more diagram. Actually, it is not from your syllabus, but just to make you understand in real time how all these 8 servers are designed in CBS IT environment. This is how it looks like. See, you mainly focus on from here to here. Just focus on this square box where all the 8 servers are there, like web server, proxy server, internet banking application server, channel server, this, and database server, antivirus server. Like these 8 only we discussed. As I said, there are many servers, but from your syllabus you only have these 8 servers. That's the reason all the examples are given in such a way to make you understand these 8 servers only. Okay. One point I would like to highlight here. If you observe in this diagram, these servers are having this background, these dots, right? Just to make you highlight that these are in a separate LAN. Okay. VLAN means virtual LAN. In your chapter number 4, when you talk about virtualization, you have 3 types of virtualization: hardware virtualization, network virtualization, and software virtualization. So using that network virtualization concept, all these servers are virtually kept in a separate LAN networks. Okay, what is the advantage of maintaining in separate VLANs? If somebody attacked this network, still you can protect all other servers which are in separate networks. Okay, majorly for protection purposes, because you are not exposing your entire network at one go. First they have to, like, see, before even coming to this place, there are a lot of things, like even this firewall is one more gatekeeper to stop all the unauthorized access. So you already have, even here you have one firewall, here you have one firewall, everywhere you will control. But one more additional layer of security is keeping these things on a separate LANs. Okay, so when they are on a separate LAN, you can write own set of rules. Okay, yeah, even if you see here VLAN 2, that means in this network, as its application server, right, you can write certain rules like only this kind of request should go via this LAN. So like that, you can write a lot of access controls and also the request controls. You can be able to build in the individual LANs. Okay, this is the main advantage of using virtual LANs. And also the bandwidth can be shared, and security can be enhanced using this virtualization LAN. This is how the CBS IT environment look alike. Okay. That's it from today's topic. If you like these videos, please subscribe to my channel, and also do like, share and comment on the videos. Thank you so much. Thanks for attending the session.